What were you discussing? What topic?
Factors on which apparent shift and apparent depth depend.
Yes, so factors on which apparent shift and apparent depth
Depends.
depend. So two factors we have already discussed, no?
No,
What
sir.
is
You were
third
writing.
one? Third one, by that time class was over. So third factor is what?
Third.
Color or wavelength. Indirectly, that refractive will depend on thickness and the refractive index. Now, as we know, refractive index depend on two things. One is the nature of the two medium, and the other is the color or wavelength. So third factor we can write color or wavelength of incident light. The third will be color or wavelength. Incident light. So as we know, refractive index is maximum for violet and minimum for red. So apparent shift or this apparent shift was, this delta was what? T1 minus 1 by mu, and apparent depth was T over mu. This was the two formula. Numericals in syllabus on this formula. You have to solve some numerical also. So if mu increases, naturally apparent depth will decrease. But when mu increases, apparent shift will increase. So we'll write here apparent depth decreases and apparent shift increases with what will be? With increase in wavelength, increase in refractive index, and increase in refractive index means decrease in wavelength. So we say apparent depth is minimum for violet and maximum for red. Whereas apparent shift is maximum for violet and minimum for red. So in this case, apparent shift and apparent depth are just reverse, opposite. Here, if apparent depth increases, naturally apparent shift will decrease. But in first factor, with increase in thickness, both will increase. Okay, so these are the factors. Now, sometimes it is asked, oh, this is a glass slab. At the bottom of the glass slab, dots are present of different color. So 7 dots are present of different color. This dot is of violet, this is of indigo, this is blue, green, yellow, orange, and red. Now you are asked, when you view from this side, where will they appear? Will they appear in same line? If they are not appearing in same line, then how will they appear? Yes. What will happen? When we see from above, where will they appear? No one. Pushkar, present or absent?
The dots will be found raised.
It will be found raised. Okay, very good. So, will the raising will be same or different?
Like steps.
It will
Yes.
be different.
It will be
Different
different.
for different light.
Why different?
Different for different light. For violet, it will be maximum, and
Like
for
here?
red, it will be minimum.
Yes. As the dots are of different color, that means different colored light is coming out. And we know for violet, what is there? Apparent depth is maximum. Sorry, minimum. So this shift of violet will be maximum. So violet will come somewhere here. This indigo will shift somewhere here. This is somewhere here. This is this place. So this apparent shift will not be same. Because it depends on. So this is apparent shift for violet, whereas apparent depth is this much. So apparent depth of violet is minimum. Apparent shift of red, minimum. Apparent depth is maximum. Understood? Yes?
Yes, sir.
Now, when the object is placed in rarer medium and is viewed from denser medium, what will happen? Here we have seen, suppose object was in denser medium, that is, a fish is in water and we are viewing from air, or a bird is viewing the fish. Where will the fish appear? So naturally it will be appearing little raised. Now, if the same bird is viewed by fish, where will the bird appear? Suppose this is air and this is water, or any denser medium. This is rarer medium, this is denser medium. So when object is placed in rarer medium, and is viewed from denser medium. Like a star. Star is in vacuum and we are in air. So we are present in denser medium. Star is present in rarer medium. Because vacuum is rarer in comparison to air. Then where will the star appear? Will they appear at the same place or will they appear somewhere else? Similarly here, if suppose a bird or a fly is somewhere here and is viewed from by the fish which is inside water, what will happen? Where will it appear? How will you draw the ray diagram? So one ray we will take, which is coming normally like this. It will go on negative. Other ray, if suppose this is, what will happen to this? It will bend towards normal, and it is going from rarer to denser. So it will bend towards normal. So ray is coming this way, but it will bend this way. It is still diverging. So no image will be formed this side. So what will be when we produce these one ray like this, other ray is coming this way. So when these two enter into our eye or this eye, so the image will be somewhere here. In this case, shift will be away from the observer. Or suppose on the bank of the river, one tree is there and fish is observing that tree. If this is the length of the tree, the fish will feel that length of the tree is up to here. Because this place will be as it is, same place, but this one will reach to this place. So length of the tree will increase. Or this is the position of bird, the fish will feel that bird is somewhere here. So it is away. Now other application is bending of stick. This one we have done in class 8 also. Bending of stick. When inverse partial. Or sometimes it is asked, a pencil appear broken when it is partially immersed in water, or pencil appears bent, or a rod appears bent when partially immersed in water. So this ray diagram is asked. This is specially mentioned in the syllabus. These two things. One, when the object is placed in denser medium and viewed from rarer medium, this derivation is also there and numerical is also there. And this one, only ray diagram we have to do this one. That is when the stick is partially immersed or rod is partially immersed, then how will it appear? Especially the ray diagram you have to understand properly. Suppose this is a pencil. So this is what we do. So when it is viewed, this is viewed from this place, this part of the pencil will appear bent. Why is it so? When our eye is here, the ray which is coming from this part of the pencil, there will be no deviation, no bending of that light. But the light which is coming from this part of the pencil, immersed part, has to pass from water to air. And naturally it will bend away from normal. So we have to draw the ray diagram. We are taking two rays. These two rays are very close to each other like this. Now, how to draw ray diagram in exam? So first you decide, okay, I have to show this point somewhere here, or you can decide somewhere here, no problem. I want to show this one here or little closer because this first shift will not be there. There will be shift. As we are doing this side not normally, so shift will not be in the same line. That is, image will not appear in the same line. So when you view from here, it will be shifted this side. When you view from this side, it will be shifted that side. So from beforehand, we will say this is our object and this is our image. Image we have decided. We will show it here. Now what will you do? You join this point and this point by dotted line and then by full line. So suppose we have joined this eye here up to here dotted line and then full line. Okay. Then second one is this one. Up to here dotted line. And then understood? So this is our incident ray and this is refracted ray. So when these rays are entering into our eye, this is appearing at this place. So this point is appearing somewhere here. But these points are appearing at the same place. So naturally this immersed part will appear at within this region only. So we will draw this line. Suppose this is so this is the position of the image. Yes, anyone? Confusion? Anyone having confusion? Yes? No confusion. Okay. So, ray diagram, if it is asked like this, you will draw the ray diagram. If simply you are asked region, white appears bent, then what will you write? The rays of light coming out from the immersed part, that is from this part, will bend away from normal while going from water to air. So while going from water to air, the ray has bent. But we will not be able to observe this bent rays. What we will feel, that ray is coming from this point. That's why the image of this one will appear somewhere here. So what we'll write? The rays of light coming out from the immersed part of the pencil bent away from normal while going from water to air. And when these rays are retraced by our eye, because we will not feel that it has bent, we will always feel that ray is coming straight. So this ray is appearing to come from here, this ray is appearing to come from this place. So at this place, image will be observed. So immersed part will appear little above than its original part. Whereas the upper part is as it is, so the pencil appears bent. Okay. In the new syllabus, only these two things are mentioned. Earlier it was the apparent sunrise or sunset, why it is appearing late, twinkling of a star, but now it is all things removed. If you are interested, you can read the book. Everything is given. Let us have an idea a little. So what will happen? Twinkling of a star. So suppose this is Earth's surface. So atmosphere can be divided into different layers. This is the rarest one, vacuum, where a star is present. We are in the densest layer. So when light is coming from this star, it bends towards normal, like this it may come. Again, it is bending towards normal. This much bending will not be there. Very little bending will be there. So it will again bend towards normal. So when we see from here, the star is appearing somewhere here. So star is appearing at higher altitude. Actual position is here, but it is appearing in this line. So we say the apparent position of the star is at higher altitude. It makes larger angle from the origin. That is the apparent position of the star. Now, why it twinkle? This layer, due to diffusion of gases, there will be always intermingling. So optical density keep on changing. As a result, the deviation in the ray changes. Though it may be very small, maybe 0.00001 degree only, but there is change in the deviation. As a result, the apparent position of the star, sometimes it is appearing this side, sometimes that side, sometimes. So it keep on changing. And that we call twinkling of a star. Whereas the moon does not twinkle. Why it is so? The apparent size of moon is very big. Means it is appearing, not actual size. Actual size of moon is very less in comparison to star. But apparent size, which appear to us, is very big. So when there is small change in the position of moon, that we are not able to notice. That's why moon does not twinkle or planet does not twinkle. Similarly, sunset and sunrise. In class 8 already we have discussed this thing, and now it is removed also. So no need to discuss again. Now some numericals we have to do on this apparent shift. Now suppose I have given one placed in a beaker 6 by 3 centimeter when beaker is filled with water. If refractive index of water be 4 by 3, find depth of beaker or water, whatever it is. Because beaker is filled with water, so whatever the depth of water will be there, same will be the depth of beaker. Yes. So here you are given this apparent shift 3 centimeter. What is the formula for apparent shift and thickness? What is the relation between apparent shift and real depth? This
Apparent shift is equal to real depth minus apparent depth.
apparent depth. So T1 minus 1 by mu. Here mu will be what? Water with respect to air. So this T we have to find. This is given 3 centimeter. Or T you have to find. Directly you can make subject T. 3 centimeter by 1 minus 1 by 4 by 3. So depth of beaker is 12 centimeter. A point object inside a glass tube appears at a distance of 4 centimeter and centimeter respectively when viewed from opposite faces. Find real position and each side of glass tube. Given refractive index of glass with respect to air is 1.5. Okay, suppose this one given. क्या हमने हो लो हमने yes. But this is the glass tube. Inside this tube, somewhere this dot is present, point object or dot, whatever it is. Sometimes it will be given point object or a dot, color dot or ink dot, whatever it is asked, whatever given. So point object is present somewhere here. What is given here? So object is somewhere this place. Now he said when the object is viewed from this side, naturally it will not appear somewhere here. It will appear somewhere here. This is the suppose this is I1, and this distance is given 4 centimeter. Okay, so from this space it is 4 centimeter. But when the same object is viewed from this side, it is appearing somewhere here. And this distance is 6 centimeters. So you are asked what is the actual position and this each side of the cube. So suppose this is at distance T1 from this place and T2 from this side. What is the relation? So this T1 by 4 is refractive index. And T2 will be 6 centimeter into 1.5, same way. Refractive index is real depth by apparent depth. So this is real depth, this is apparent depth. So apparent depth from both sides you are given. So it is 9 centimeter. That means the object or the dot is present where 6 centimeter from this space or 9 centimeter from this space. What is each side? T1 plus T2, so it is 6 centimeter plus 9 centimeter, so it is 15 centimeter. Okay, this way you can solve the problem. Only 2-3 problems are given in your book, so we solve that. Next, we shall start the new topic, that is critical angle and total internal reflection. If you don't have any doubt, if you have any doubt, next you ask. Otherwise, we will start new topic. Is it okay? Yes?
Yes, sir.
Yes.
Yes, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.